Hey everybody, welcome to Getting Started. We're going to, catch you up on my first 10 hours of looking around the language and the designer and ultimately try to show you a good way to learn how to learn. If you're not even sure how to know where to getting started would be, this will be for you. If you've done a little bit of messing around, I think you'll still find our time together quite valuable. So let's just dive right in. First thing I want to do is to create a part. We're going to create a sphere, and we're going to. What I really like to do when I'm learning a new language or when I'm working with a new system, any of the problems we're solving is really think first of what is the next big thing I could do, or the next most interesting thing I could do, or the next most difficult thing I could do. What is that next thing that I'm going to be able to say, hey, this doesn't happen right now. I'm going to go figure out what it takes to make it happen. I'm going to implement it, and I'm going to learn from that. So let's get the ball up, and then we're going to have the ball move around and have the ball solve some puzzles, and ultimately just keep asking questions of our development environment, asking questions of the internet, asking questions of the Roblox cookbooks, Lua, the scripting language, all sorts of fun things. So that's what we're going to do. Let's go do it. First things up in starter GUI. I'm not quite confident that's where it belongs, but it'll work for now. Insert object, and we're looking for a script. Alright, in this script we would like to make up a local variable, and you're just making things up. We'll learn as we go. It's okay if none of this makes any sense. I'll make it make sense early enough that you can enjoy our time together. A local variable for our sphere, let's call it a bubble based on some things it's going to do later. And this is going to be instance new part. And this bubble needs some properties. One of the ways of many that you're going to use to learn about things is to come back into the designer and go ahead and let's open up our IDE. I would like a home part sphere. And once I touch this sphere, over here, I think we could give it a name. And when it's selected, either in the designer or over in the explorer tree, we can see its properties, the appearance, some of the data, behaviors, etc. So we don't have to guess. We can go back over to our script and we can say, okay, there's a brick color. Bubble dot brick color equals brick. We know there's an enumerator for brick color, so we could just do a random. An enumerator is just a list of attached values, and we're going to show color, red, blue, green, etc. Right. Not a lot of magic. Once you get it figured out, it's all just really simple lists. It's very simple constructs, and it's available to everyone, right? Every type of person has gotten good at this. It's going to become more about your willingness to debug and to try again and to ask different questions of your environment to see how to do things. And here we're going to need to pass in workspace. Alright, we have our brick. Now let's turn that instead into a ball. It still remains a part whose shape equals ball. Awesome. Alright, so in code, we've added a script. It will run on the server, so one copy for everyone to share. and we have one ball. Now let's do some things with the ball. Let's move it around. And a lot of the behavior and all of the behavior, it seems, is based sort of on this tree structure, that we're going to have this part that we've created, and we're going to create children or attach as parent, to some child artifacts, and they're going to adorn it with new behaviors. So when we look at the new behavior, we want some movement. So we're going to use body velocity. And this is just a little bit of playing. Like I said, I'm about 10 or 12 hours in, so I'm kind of referring to just some of the other experiments I ran. Feels like body velocity into the win. So I'm going to bring over and again, these variable names, you just kind of make it up, anything you want. It's totally up to you. There's a few conventions to follow, there's some rules, but ultimately that just it's local in scope, and it's got a name, and here now it becomes a thing, and here happens to be an expected parameter for that thing, an expected property of that thing, and giving it some sort of a value, vector 3. It uses a lot of these three-dimensional vector points. It's all easy to read about. We'll start searching some things on the internet here in a minute. And the velocity. So I know a 2 here is going to be the speed in which it heads up, I believe. So let's just check that out. Our ball did not move. I know why. Do you know why? So we forgot to anchor it, as we just mentioned. Parent equals bubble. And I'm hitting F5 to run the project, and shift F5 to stop the project. And as we go, I'm going to encourage you to learn more and more of the hotkeys that just help you be more effective in your development environment. Something about this is not working out, so let me reference here. Velocity, got the parent. Parent appears to be capitalized, and I may not. We may want to slow down and learn a little bit more about if it's case sensitive. Well, still not moving. A couple other attributes, I guess, that are important. There's something about being anchored. That wasn't it. In fact, it made it unhappy. Unhappy. We see down here an error message that says anchored is not a valid member of part. So we know exactly what we've done. Let's look here. Anchored. Again with the caseness, so it appears to be case sensitive. Archivable, can collide. These are all properties. Let's look at that sphere. We still didn't get it. Let's fix this, and then we'll look at the sphere. Let's borrow all of these. Anchored, archivable, is can it be copied, can collide, and transparency. Anchored. I'm sad. I really was hopeful that anchored was to blame for this thing being stuck on the ground. I want to go with you. So let's run fewer experiments at once, and we'll learn from ourselves. Is it can collide or transparency? So transparency, not. Transparency full, it seems. So sometimes you just gotta learn. So no invisibilityness. I'm just not with you. However, we have our motion. Ta-da! We're just getting started. We're asking some questions. We're saying, okay, can I make a ball? Can I make a brick? And then can I make it a ball? Okay, it's a ball. Now can I make it float? Oh, it didn't float. Well, why didn't it float? What can we do about that? maybe I'm looking at it and the bottom is a little pebbly. Perhaps, well, let's get another sphere out here. Right. And let's look at what happens about these surfaces. And so, I don't know, it seems like the nature of it is that the bottom surface is smooth. Let's see if we can say bubble dot bottom surface equals smooth. I don't see like a surface enum or anything. I think it's just text. Just try it, right? It's just pretty quick and easy to just try stuff. So I'm not seeing the pegs that I think I was seeing a minute ago. Let's back off some of the this. See if I can float with it now. Come on, yeah! Uh-oh. I did not think of a way down. Alright, we got a ball. It can float. We had some weird behavior where it was stuck, and that made us unhappy, so we figured out how to smooth the bottom, and that made it not stuck. That made it movable. Now we are moving upward. I want to learn more about this. The documentation has left me, it leaves a little bit to be desired. And part of it's my learning style, but I like to just experiment, right? I'd like to just say, well, I wonder what if I put that to 0 and I put this to 2, what happens? I expect it's going to go to the right of where I'm facing. Wah! It tried to go to the right, but it seems, oh, look, the top is sticky, and I think that's causing it a problem. Let's take a look. What's the top of a sphere called? Top surface. We also might want to make sure this other sphere isn't interfering. I'll kind of scoot him over. Top surface. Run that. Still having a lot of friction. I wouldn't expect, unless we don't have a force. We do have a force. It appears to be a large immovable object. Let's add an angle and get it off the map and see if that helps. So now we should go to the right and gently slope upwards. Theory. Tested. Maybe it's just my... Oh, there it goes. It's doing this thing. Alright. And if we clear these, now if I change all of these at once, I don't learn anything. If I just change one and I try to see what happens, I think it's going to go backwards. Backwards. Pow. Oh yeah, it's got a lot of force. It's going backwards like a rolling stone. I can't outrun jump. Anyway, so that's interesting, and I think this max force is what's up with that. Now I don't have a clue about these numbers, so let's go learn something. Body velocity is this object type, and max force is the property that we're trying to learn about. And this is Roblox. So Roblox, body velocity, max force. And I'm going to use my control key and then just normal click with the mouse, and these are all opening in a new tab. Control tab, and moving around here. Body velocity, object to apply force till it reaches a set velocity. Used for moving objects at a constant rate without having to keep calculating the force. Velocity could be 0. Make it reach the goal. So vector 3 max force, that's the maximum force, can be applied on each axis to reach the goal. So that seems to suggest in this theory, this is the only number taken into consideration. Let's see if that holds true by breaking that number. Now this thing is super unmotivated, perhaps, or just less motivated. 500 is a pretty big number, evidently, in the world of sports. But this time I can kind of stop it. Oh, look, how fun is that? It really wants to go where it wants to go. So, unexpected behavior? Interesting. What does that mean? Future only holds the answer to that question. More tests. So these probably have no bearing, based on what we just read, on how. What was that? It's like somehow I hit the ball. These do have a bearing. Alright. So interesting. It really is, how strongly opinionated is this ball to head in that direction. And it's not a weak, it is a determination of each of those directions. So when these were max, here, this will make a perfect. So it mostly wants to go in a direction it wants to go. It really won't go one direction sideways, and it'll easily go the other way sideways. So we should see that. Cannot. Hey, come back here. Trying to run a test. Cannot move it that way. I expect I could gently move it this way. Almost. Maybe we can try a smaller value there. Could definitely move it backwards. It became super backwards light. And I can move that way. Alright. So, all fun, interesting things. There's a couple of other ways other than body to velocity to travel, but for sake of what we're up to, that's going to work. Now, crack the knuckles. Let's do some wizardry stuff. Let's do something interesting. I want to send this ball on a square path. I currently don't have a guess how I'm going to do that. Excuse me, it's late. But we know enough now. Copy this. Let's just have it be super opinionated for now. And we're gonna stay on the ground. We're gonna go left, and then for a little while, let's say 2 seconds. Then what we want to do is loop a couple of times. How many turns do we want to make? 1, 2, 3, 4. What is the syntax here? For do and what doesn't it like? Expect an identifier, got a 4. Alright, what does a for loop look like? For I equals 1. Got it. Alright, so 4 times we want to turn. Well, we'll come back and optimize it. We're going to wait 3 seconds. Then we're going to make 4 turns. This time we're going to go no more that way. And now we're going to go that way. Then we're going to go this way. Then we're going to go this way. I don't know. Let's see. Or we're gonna sit here with no error messages and go in no particular direction at all. What is up with that? Aha. It's not attached early enough for any of this to be played out. So once it's created and given that first vector, we're going to attach it. Then we'll do some other goofy things to it. Yeah, that'll help. What's up, buddy? What's up, buddy? Oh, yeah. Oh, yeah. I love it. I love it. I love it. Code is just fun. What a ridiculously goofy thing. Let's do something. Let's do something. So by keeping the same time but dramatically increasing the speed, we're going to cover a lot more distance. This might, this is what robots are good at. And we could take you here, put you here, bring all of y'all into play. We can bring back that 4 structure. I starts at 1, it goes 4 times, and it does a do with an end. These are all gonna tab. And what we're doing here is 4. Okay, we're doing 10 loops of this. Let's see what happens. We got, whoa, it's out there. Do you see it going? Oh, here it comes. What? That's legit. And it's a robot, so how ridiculous can we go? After it does 1 lap, 500, maybe I don't know what the max is here. We can run a test. We can find out. Alright. Where are you at, buddy? Alright, here we go. 1 lap. After 1 lap, we're going to have a hard time finding it. Whoa! My goodness! It's gone! And I died. I was too near it when it took off, I guess. I don't know what just happened. Wow. When it floored it, it made me shoot off into nowhere. Let's do okay, so we're gonna have to turn much faster. That ball was violent. I gotta get out of the way. Alright, we're gonna turn much faster, and I'm gonna get out of the way. I'm getting on you. Why are you moving? Okay, here it goes. Look at that. Oh, how fun is that? What's it gonna do at the end? It's gonna stay 1 course. I don't know what course that is. What has it got? 10 laps? 15? How many laps did we give it? 10. Whoa! And there it goes forever. Brilliant. Alright, alright. Now what we want to do, is every time it comes in, start speed equals 50. 500. And in here, we're going to going to do start speed times I. So we may get an overrun. That may end up being bigger than what it likes to deal with. So we'll bring this loop down a little bit to like 3, or 3, 4, 4. It's a robot. Maybe it could handle the abuse. And what's going to happen at the end is let's explode the brick and delete it, because it doesn't actually explode when things explode. So we'll need an explosion instance dot new explosion. It's alright, I've got one over here. Explosion. And here we go. It's got couple cool things we're going to learn here. Just want to get the properties of explosion that we need first, and all of these, you know, just a bunch of trying and searching the, you know, the reading through the code book, the recipe book. And here we go. So we're gonna set the position up to where the bubble is, and then we are going to set its parent, set the blast radius, and power flow. Well, so it'll just be fun to watch. And then the last thing we're gonna do here is unrelated to the explosion. And that is to completely destroy the bubble artifact. We wouldn't be able to do anything with it after that. We couldn't change its color. I mean, it's gone. The explosion just hurts us, it seems, not the actual items. So let's run it here. We should see a ball do a lap, and then it's going to do 3 laps that get faster and faster until it explodes. Whoa, even faster. Oh yeah, it's getting faster because it's taking a wider girth. And it popped. Alright, we know where to go stand. We know where to go stand. We're gonna do this. Let's get our angle about us so it's out there. Gotta not get tagged. It's me, right? One more. Nice. So that's quite a bit of stuff we've covered in just a little bit. You know, we created some local variables. In this case, you know, you can imagine you instantiated a bubble object if that's useful, and now that you have that bubble in memory, you can do things to it. Here's one that kids enjoyed. Let's get this to quit being ridiculous. I don't want you to travel so far away or so fast. I want you to just stay near us. And let's do a couple things. First, let's get in a fun new loop here. Alright, we're going to introduce something pretty complicated, but just hang out, no big deal. You noticed when we had all this code up, where were we a minute ago? By the time you get to bubble destroy, that's way down here, and it waited. You know, all this code ran and it ran and it ran, and then it got to this code. So everything so far is happening very sequentially, very procedural sort of language. But what I want to do now is I want to fire off a disco ball. I'm gonna bring in a couple of concepts here. So first is this idea of a function, And let me see, I don't think we have a sense of a return variable in a function. We just give it a name. This is going to be change my color, and it's going to accept bubble, which can be anything really, anything that inherits from part. I didn't mean to say that. Yeah, a little nerdy. Anything that is a part. So better is to say any part, perhaps. And this language likes then and end. Nope, function. What is it like? Okay, I guess it's just an end statement. So change my color, any part, and what I want to do is, here's what I want to do, a couple of things. I'm going to wait half a second, and then I'm going to take any part, and I'm going to take brick color and set it to brick color random. Now, if you call this in a loop, the game will stop and it'll just be working, you know, on this changing the color of your brick until your loop is over. So what we need to do is to call this function on a separate thread. Now, first off, it'd be easy for us to say, oh, at every lap, at the bottom of every lap, let's say change my color and let's pass in bubble. And you know, that's fine, that would work in theory. Wherever that cat's at. There, it's yellowish. It's blue, silver. Oh, where it went? Reddish. So I think we're good that it's, you know, it's changing its color all right. What we would like to do ideally is to use a coroutine. And we like to call this pretty early and just have it go do its thing, but it's got to be after bubble gets created. We could just do it here. And brick color randomize equals coroutine.wrap. And we're going to have to, I think it's create one. No. I'll come back to this, I'm not sure. Let's look. Because we need to pass in a parameter, we have to do it a little different. We have to, where's resume? Coroutine create has resume. Alright, so coroutine create, and now we're going to call this change my color function, and then we are going to coroutine.resume change my color, and we're going to pass in bubble. Does that feel right? It feels right. So in theory, throughout the entire life cycle of this cat running around, and let's bring him way back to planet Earth here. Let's say let's just bring this way down, and let's bring this way down. To wait so long to turn, but at those speeds I don't think it got very far. Alright. It is beer Rogan. Brick color randomizer is not a member of part. Because I said this for no reason, what I might say is, I don't think I need anything. Let's see. Unhappy. Bad argument. Coroutine expected. So, how does it deal with the name being the same? Unhappy. Looks like it just wants let's say and that is that syntax. That's not helpful. That might have been part of the problem. Do we have a ball out there in cyberspace? We do. And every half a second, this ball is not changing colors. Stop traveling, my friend. Let's comment all of this out. Comment section, and let's have, wait 10 seconds here. And coroutine, change my color. So I'm wanting to go clean some of this up. That'd be good. That'd be, I can handle that. And it seems headed somewhere with great enthusiasm. Are you changing colors, my friend? The largest gobstopper ever. You're not. Ooh, but you do explode. Why, oh why are you not changing colors? Any part. Change my color. The function gets called once. So, for a while, the game is alive. I don't know how to say that. So for now, we'll just say I equals 1. 100,000 loops. Do. Alright. Now, that feels better. And it's a robot, right? So we can abuse it. How fast can it render? Blah. What if there is no wait? As fast as it can loop. Oh, it can loop faster than it can render. So there you go. It needs a wait. How much weight can it downgrade to here? Oh, it can do it. Ah, it hurts. That's hilarious. So there's that. Oh, I forgot it explodes. Who's coming up with all this stuff? All right. That's enough of that. So that's a lot to take in, right? Functions aren't scary at all. It's, print Bob. It doesn't take in any arguments, and then it ends, and then you print Bob. And anywhere in the main execution, right? So these functions are defined in the main execution. This variable is defined in the main executions, using indentation to kind of help make sense of that. But right here, I could say print Bob and call it, right? Print Bob and call it This is just a pointer to the in-memory address of where the function is definition is stored. But print Bob and then call it should print Bob to our demo here. Print Bob, and it's probably available. It's not available because it's local. It's not available. All right. So that's what's up. Functions, and sometimes you want those to be blocking calls. Sometimes you don't. To prove it's a non-blocking call, let's wake up just a little bit of this. Do one loop around the track, and you'll see that the rest of the code still executes. Now, if we didn't use a coroutine, let me slow the change down so the robots aren't like going crazy, making the color change all the time. You'll see it move smoothly, right? We must have a wait in here I wasn't thinking of. So the bobble is off and it's changing colors. Right. Now, if we do not use coroutines, and instead we just call change my color and pass in bubble, it will change its color. We made something unhappy, but it can't go do anything else until 100,000 iterations of color changes have happened. It's stuck here doing this, and when it's done doing that, it'll be able to come back, exit here, and return to moving down this page. That's, so sometimes you want some, sometimes you want the other. You need to balance, the constraints and processing capabilities of the devices that you're targeting. I assume all of that stuff to be true, and you can learn more about that. All right, what is the next great act? What do we got to find something interesting that drives our learnings and pushes us past a point of what I'm comfortable with in my first 10 or 12 hours of looking around, so you can see what it's like to research and search. So far, we've been able to pull this off just by asking questions of our environment. We dropped a sphere out on the table so that we could look at its properties and decide what it, oh yeah, bottom surface, top surface, that's what it's called, and setting those behaviors. Oh yeah, anchored. Oh yeah, can collide, right? Look those things up inside the IDE. We get an amount of data from typing things out, and you see me kind of using the IDE to teach us what we need to do next. And then having a good, strong sense of development principles certainly helps. This idea that I must be able to somehow go off on a multi-threaded adventure. I must be able to spin off a new thread to do a thing that was non-blocking. So that knowing I could do that made it easy for me to go look that up. I knew where to start the search anyway. All right. Got a ball. We can move it around. We can make it explode. We can make it fly. Let's have multiple balls, and let's let's treat them for now like bubbles, and we'll just have them start to kind of float up, and we'll leave the explosion at the end because that's always fun. And what we're going to want to do then, that's all we can clean that up. Movement, we want to go up for now, and we want to have several, so something, again, these are all variables, right? Blah 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 equals 1. It would, what does it want? Comma 15. Do end. This is legit. This is a variable. This is going to increment to be a 1, then a 2, then a 3. Just whatever this is. Happens to be variable I is pretty common. And for 15 times, we'll do 6. We want to create a new bubble. So we're going to come clone the bubble we've already made. No, we don't want to do that because that'll actually create a weird dependency later. We're gonna bring in creating a new bubble. We're gonna go ahead and bring in the coroutine, shape, movement. We want all of it. Putting it all inside of a loop. Alright, so 6 times it's gonna go through and create a bubble. I don't know that I gotta change anything for this to work and work fine. This is unhappy for now, so comment that out. I didn't do any weighting, so those bubbles are gonna be, yeah, like stacked together. Alright, that's pretty cool. And we could certainly come back and just wait a minute and hit play there. And there should be some spacing, perhaps. That's interesting. I wonder, it might be because I sat on them. No, we've got huge mass. They're not evenly spaced. Nope, I don't know. That's weird. But keep an eye out for that. Maybe the weight is not the optimal way to go. Let's bring back a little of that movement and see if we can make these bubbles wobble a little bit as they ascend. So just like the color change, we're going to want some sort of a subroutine we could call, and this is going to be called Wobble the bubble. And again, we could about do this to any part, and we're going to need to run off on some goofy, ridiculous loop, and we're going to need to do some weighting, and we're going to want to adjust the direction this thing is headed in. And we want to gently grow the time and make like a tornado of these things. So this weight starts at 0.2, and let's just say it gets a 1/10 longer as I increases. So that'd be plus I times 0.1. Make it even smaller, and what we want to do is take that part and change its directional velocity. Now how do we want to rotate between those? So we're going to need something else here. We're going to need a vector list, and that's going to be one of these. And inside it, we're going to be able to say, well, it won't matter. We'll just need vector 3.new. Alright, so that's up. And we want a couple of values here. We got up. We have left. We have forward. Think those are the values we'd be after. And so down here in our vector list, we would want to say, how do we want to do increments of 4 here? If it's evenly divisible, that's not going to do it. We'll just we'll spell it out, and then we can optimize it later. We'll keep it simple. Robots are good at this stuff. So the counter is going to start at 0, and counter equals counter plus 1. If counter equals 1, then alright, else if equals 3, else if equals 4. And what we're going to want to do in each of these cases is just call a different any part dot any part first child body velocity vector, right? So let's see here. Any part. You know what we could pass in that would make this easier? For the movement, let's pass in, let's do it down here. Instead, let's pass in a body velocity. Any body velocity. Then we can skip to the chase. Any body velocity dot vector equals vector 3 equals vector list of 0. And is that all legit? Is that a vector? No, it's a velocity. Velocity. This one, and then that one. And what we'd want to do then is control equals 0, so that particular 4 tick counter just keeps resetting itself. Alright, that feels legit. We should be able to wobble the bubble. Let's see what we did down here with renaming things. Gotta be careful there. Wobble the bubble. And wobble the bubble and wobble the bubble. And this time we're passing in body velocity too. Let's see what we got. don't appear to have any wobble yet, but we did have a pretty low. Oh, we got errors. Bad argument. Velocity. Vector 3 expected got null. Alright, time to debug something. We got something interesting enough. We broke it. Core GUI. New follower. Crash. Main script bot. Player down. Playlist module. Because I don't feel like the stack end is helpful. Feels like something's already gone really wrong by then. Vector 3 expected got nil. Let's pretend like that's what's up. Let's look at VectorList. VectorList is 0 based, right? VectorList. VectorList is not 0 based. It also seems to have too many values. It wants to go up. It always wants to go up. So that stays down here. Alright, so... Oh, come on! What is up? We want way more tornado than that. Way more tornado. How do we get more tornado? Alright. Get rid of those breakpoints. Is it pivoting on all 4 axes? That looks pretty smooth. And their path should widen. We want way more tornado. And we want more balls. And we want them faster. It's a robot. We can just do what we want. So we're going to wobble the ball. Wait time is growing. Now it's going to grow by I. And we want more, and we want them, you know, much faster. We appear to have a tilt, Houston. Or do we? We have ourselves a bit of a helix or something going on here. Wow, how fun is that? When does it break things for obnoxiousness? Break things for obnoxiousness? We got one final trick, and I gotta close it down. It is, I'm not telling you, it got late. We're gonna do one final bit of obnoxiousness, and we'll get together again another time. I hope this has been useful to you. I'm gonna speed it up a little more. All right, it's another. We're gonna go deep, and it's okay. It's great if you just come back and say, "Last time nothing made sense. I'm gonna try it again." It's okay if this doesn't really make a ton of sense, but we're gonna create a bubble list, active bubble list, Yes, we are. And that's going to hold all the bubbles. And when we get to the bottom here, we want to add active bubble list. We want to add bubble. Okay. And at some point, which means we need to get these bubbles off our main thread. So generating bubbles is about to become another function. Just bear with me. Do a little housekeeping. And what we're going to do out here then on the main channel is pop bubbles. And we are going to iterate. What is that language for I underscore? We have to look this up. We need to iterate on a hash table. On a hash table. And we're gonna need to deep copy. Bubble in pairs local bubbles do. Alright, we can do this. For I equals 1 in pairs. Bubble in pairs. In pairs. And active bubble list. Do. Key value. Got it. Okay, so in this case, this is an object, and we're looking for the key value in that hash list. And while we're in here, what we want to do is active bubble list. Well, we're going to want to explode the bubble and then make it disappear. Right? Explode, disappear. So we might have pop bubble. And this is really any part, right? And then end, no then. Pop bubble takes any part and it's going to attach that explosion code we were working on down here. And it just says any part. That's where that happens. And then any part gets destroyed, so it really disappears. And we'll say, and let's be goofy. You got somewhere to be. Well, we don't want to die. And explode and disappear happen all at once. Pop bubble, and we passed in bubble. Actually, well, we'll come back to that. Yeah. Let's just run this. All right, we're gonna want to get out of town. We don't have no bubbles. Oh, we never called. Now that they're all cutely wrapped in functions, nobody's actually doing any work. It's all just describing work that could be done, right? We have a few local variables, some nice functions. But what about the work? So we need another coroutines. We're going to call it generate bubbles. coroutine, create, and this is pop bubbles. Nope, this is generate bubbles, and I don't feel like you're supposed to call that. You're just passing in a pointer to that function and its memory address. We're going to create that bubbles, and then coroutine.resume generate bubbles, and now we don't need to pass nothing in, so this cat can be wrapped. Is that right? And then we just say this. I think it's like that. We might have to look that up. We also want then on a timer, let's say, let's put a loop around our loop. We're going to need a different letter. We can't use I. And this time we're going to say wait for it. And it's going to be, oh no, this is just a number. So it'll do this like 10 times. Goes 1 to 10, and then do. And what we're going to do, here is wait. We're gonna wait some amount of randomness, and then we want to have up to 2 digits. And then we're going to need to trunk that ceiling of that. So somewhere between 1 and 10 seconds I expect. I'm going to print this and just double check that we're in the neighborhood. So every now and again we're going to go pop all the bubbles in the active bubble list, getting it out of the array. We don't have to do that tonight. Let's just see. Let's just see our little project. Let's. We tried to add to nil. That didn't work. That was in an attempt to generate bubbles, and we wanted to add to the table active bubble list, local active bubble list. It is a table. We want to add a bubble. Let's see if table does not have add. Does not have add. It has insert. Table position value. Link through the table, so it puts it at the end. Table insert. Table insert value. And if you leave that out, it'll put it at the end. Alright, so we got stuff happening. We got our tornado forming. We did set the boom, so let's get away a little bit. Oh no, it never printed that it was gonna explode. Did we not call the pop bubble, pop bubble, pop bubble gets called in here. 1 to 10 pop bubbles. Somebody called pop bubbles. We got generate bubbles. Right. Still not seeing in the output. this. That's what I want to see. Pop bubbles. So we need to go look at coroutine wrap. I haven't used that. See if coroutine create creature that you because you need to use or resume. Let's say you don't even want to do that, you just want to wrap it. But if you want to wrap, I don't want to write it in line. Wrap. Alright. So it doesn't want that, but it did generate bubbles. Let's, but it's probably blocking. That would make sense. So let's try it like that. And like that. Bad argument, random seed, never expected, got no value. Bad argument, random seed. Random seed, where are you? And random seed. I was not using seed, I was just using random. Alright, 9 seconds is what we got to get out of here. Got that 9 showed up in our console over here. Alright, what's happening right now? What's happening right now? What's happening right now? Hello, what's happening right now? Oh, I got too close! Is that beautiful? I don't know. Maybe not. I'm not quite happy. I want just a little more spread out. It's a nice looking little chunk of code. First, well, really my third time sitting down to the Roblox anything and to this Lua language and just punching away at it, asking it good questions. I hope you're enjoying it. I'm gonna make one more big mess and then I'm gonna get out of here. How do we make this thing spread out further? Spread out further. That's how fast it's going up. And as those go up, we've been wobbling them. Wobble is its coordinate and its wait time. And we thought by increasing the wait time, that would, but that's going to be slow. I mean, we could certainly increase its factor. I don't know if that's broken. That's what that is. How fun is that? Look, the invisible ones that don't exist anymore, I think, might still be exploding. No, they're not. Destroy function worked. Alright. My brain's tired. It's gonna have to be it, kids. That's gonna have to be it. We're gonna speed it up. Generating the bubbles. We go even faster. And those bubbles are not gonna have a strong opinion of left and right. That'll be new. So certain things are gonna cause them issues. And what else? Made them faster. Circling. Wait time started at 0.2. Let's see, the gravities, they're not so opinionated. Oh, yeah. And that, my friends, is the end of that. Have yourselves a good evening. I hope you've been entertained. I hope you learned something. We're going to build some more goofy stuff. I don't know why. We'll come up with a point next time. Cheers. Have a good one. Bye bye.